and infrastructure side of the business. And I'm alongside with my colleague, Andy, who is on the sort of the DevOps and platform side of the house. And Andy does a lot of the enablement and training for us, training sessions as well. These pictures of the two of us are pre-pandemic. Our post-pandemic pictures look a little bit more like Tom Hanks in Castaway, if you've ever seen that. So maybe we'll have to update those for the next time. But for now, good enough. So what are we going to talk about today? We're going to talk about how application portability and really the security and the scalability around those apps have evolved. We're going to talk about some of the business drivers that sort of wrap around an enterprise Kubernetes platform. We're going to talk about some of the changes that are coming to Kubernetes to be aware of so that you can prepare for. We'll also be discussing a little bit of the technical challenges with container technology. Those two bullets kind of go together, the changes from Kubernetes as well as the technical challenges. We'll talk about what the new landscape looks like relative to containers and what are some of the benefits. Followed up at the end of the session, we'll do a short demo. Andy's going to kind of run through and show you some of the new modern tooling and just do a demo to show some use cases there. And we'll follow it up by a Q&A afterwards. So a little bit of housekeeping, everybody. You know, if you've joined in, your mic will automatically have gone on mute. If you could just stay on mute, there'd be an opportunity at the end of the presentation here to do a bit of Q&A. But also feel free to post any questions you might have in chat if you prefer that route. So a little bit about us. Our company name is HighVail. Stands for High Availability. We've been a longtime Red Hat partner for over a decade. But we've been around for about 18 years in the IT space. And like many folks back then, you know, we started out as an infrastructure and services type of company. Like many folks today, we've pivoted a number of years back, and we took all of that infrastructure knowledge and know-how, and we've applied it to a modern way of doing things, a modern approach using modern technology. And we've really built a practice around more of a services-led business to enable our customers or help enable our customers to get from that more traditional way of doing things into a more modern approach and all of the benefits that wrap around that modernization. So these are kind of three pillars that we practice. Or three pillars of our business here, practice areas. We do an awful lot of work around DevOps. So the Devops philosophy, the Devops principles, and the tooling that sort of adheres to those principles. We do a lot of work in cloud around application modernization, but around the infrastructural components of that offering. Services, you know, again, I introduced Andy. He does a lot of the training and enablement. So we'll do coaching. We'll bring teams up to speed. We'll take a use case that a customer may have, and we'll wrap a bit of a demo around it for the purposes of enablement, do custom enablement, things of that nature. And of course, cloud and Kubernetes consulting as well. We do a lot of that. One of the top solutions that we offer is really automation. We approach things and infrastructure in general as building blocks. They're like little Lego components that you can snap together and do some really interesting stuff. But when you modernize the technology, it allows you to do some really, it really opens the doors, the floodgates actually, in terms of what's possible and what you can do. So automation wraps around a lot of that. Containers and platform, we're going to be talking about that today. Infrastructure as code, we'll mention that today a little bit. And of course, day two ops, which is all of the management and monitoring, and sort of the life cycle that wraps around more of the platform, but also the applications. Oh, based out of Toronto as well. I don't know if I mentioned that. So again, a bit of an overview. We're going to look at the future of container runtimes. If you don't know what those are, don't worry, we'll talk about that. We're going to look at Kubernetes and specifically the diminishing role that Docker is playing. Kubernetes and Docker were very coupled, and now things are changing, and we're going to talk about that a little bit. We're going to talk about the container runtime interface and some of the tooling that goes around in that, as well as I mentioned, a technical workshop that we're going to talk about 3 particular tools that we mentioned here, Podman, Build, and Scopio, that Andy will get into in a lot more detail as we go on. So just to level set, I wanted to talk just generally about containers, kind of at a high level, so that we all know. Some people might already know about containers and what they do and all the benefits, but I'm just going to go through it anyway, just at a high level to sort of level set with everyone. So containers, I like to compare containers to virtualization. Everybody gets virtualization. It's been around for 2 decades. And with virtualization, just like in the slide here on the left, you have some physical hardware. You've got an operating system in virtualization, and generally that operating system also provides the virtual functionality. And then you have virtual machines, which are just sort of an encapsulation of a physical machine running on hardware and multiple instances of it. Each virtual machine virtualizes different components, and it has its own operating system. And then you layer your application on top of that operating system within the VM. Containers are a little bit similar, but a lot different. They still need hardware to run on, so you have a host. Could be physical, could be virtual. You have some operating system. In our demo, we're gonna talk about Red Hat Enterprise Linux. We're using that. You have a container engine, and really all that is it's a mechanism that allows you to run containers. That's it. And then you have your containers, and within those containers you have it's really basic. You have an application, your application, the dependency that that application need to run, and not much else than that. And you basically wrap that container up in this extremely lean package that you can run anywhere. Container orchestration is really container management. You can think of it as that. When you have multiple containers, you need a way to manage those containers and wrap policies around the containers and do things of that nature. Check the health of containers. That's where container orchestration comes into play. It's that piece, and often container orchestration and Kubernetes kind of are used synonymously. There's actually another column. If we shift a little bit over to the right, not on the slide here, but there's container platform. And container platform adds kind of another layer on top of this. It generally provides a nice web interface that you can log in with access controls and things of that nature, some dashboards so you can see what's going on in your environment, see what's deployed where, and kind of see the health of everything, and do some Kubernetes type of actions within that GUI. So if you prefer more of a GUI approach, you generally get that in a container platform, whereas Kubernetes just offers a sort of a command line interface. So why would you containerize applications? And I'm going to go through this kind of quick. These are some of the benefits of why any organization would want to adopt containers. If you're doing this today, you probably know of these advantages. But if you're not, if you're looking at this, if you're considering it, if you're thinking about it, here are some of the key aspects of why you'd ever want to containerize an application. And the first one has to do with efficiency. Today, everybody's, I'm guessing, is using virtual machines in their environment. They probably have been for many, many years. Virtual machines still have their place. They're still excellent, but they have a very large overhead. A virtual machine virtualizes a computer, and there's overhead in that process. It has its own full-blown operating system. There's overhead in running that operating system. And then you've got your application that runs on top of that. So your application is getting a slice of all of that stuff, but there's a large package, a large footprint. Containers are 180 degrees in the other direction. They are by nature extremely lean. They don't use a lot of resources, and really, because they're so lean and mean, the application density that you get is a lot better than what you did with virtual machines. If you remember, again, about 2 decades ago, there's a huge push throughout a lot of organizations to consolidate from physical onto virtual machines. And the proposition was a pretty simple, economic proposition. And that's, you don't have to buy as much physical stuff because you can now consolidate those workloads centrally on fewer central hosts. So containers have sort of upped the ante. They've furthered that consolidation play. So there's a big cost component. You're utilizing less hardware. If you're buying hardware for data centers, that means cost savings. If you're running in the cloud, that means you're not running as hot as you would if you're running virtual machines. There's a cost savings benefit there. The other benefit that gets talked about a lot, and maybe not explained as well, is portability. A container, by its nature, is an open format. Whether you're using vendor A to run that container or vendor B's technology to run that container, they run exactly the same. The underlying container image is exactly the same and compatible. It's a global open format. So if you want to take a container that you're running on premise and you want to run it in the cloud, you can do that unchanged. If you want to take that production grade container and run it on a developer's laptop, you can do that. And it'll run exactly the same in all of those environments, regardless of the underlying infrastructure. So it's a very flexible and powerful way to run an application in a really efficient way. Containers are sort of an infrastructural building block. They provide a lot of benefits. But when you tie those benefits, as I was mentioning before, into automation, into some of the DevOps style approaches, those DevOps principles, they really lend themselves well to be able to integrate in those cases. They're also programmatic by nature. So it's an infrastructure as code type of approach. You have a recipe that says, do these things, and then at the end of it, my application is going to be inside of the container. Because it's programmatic, that programming can be stored in a source code repository along with the application. And the developers can take ownership of building those containers with the dependencies that they need in order to do this. And they can integrate it into existing workflows. So instead of deploying a virtual machine on or an application on top of a virtual machine on top of an operating system, you deploy your app in a ready to go, ready to run container with all of the policy that gets wrapped around that. Speed of delivery, I mean, these containers are fast. They don't contain an operating system. So they start as quick as your application can start. And they have the inherent benefit, so long as your application works with it, is to scale out, scale horizontally. And security is a really, really big one. You get improvements with security because you isolate, one container from the other container, and that's great. But also, the benefit from a security perspective is when you have a virtual machine, you're running a full-blown operating system in that virtual machine. You have a pretty big target on your back because you have this baggage that you're carrying around associated with an operating system. In a container, you only have the dependencies that your application needs to run. So you have a much larger or much smaller attack surface for anybody to go in and to compromise a container because, again, we're running so lean. There isn't a lot of opportunity to hit on various things. The other benefit from a security perspective is that you can't access anything in the container unless you say, I want to make this service available that's running inside the container. So you've got that by default out of the gate. So why Kubernetes? And this can also say why container platform. Well, we're going to use those sort of synonymously here. So we could be talking about either one. Really, the portability aspect gets upped, the ante gets upped a little bit because what you can do with a container platform and is you can associate it with different environments. You can say, I have my local environment where I'm running everything on premise, but I also am reaching into cloud provider A and cloud provider B. And when I'm deploying a container, I'm now talking with Kubernetes, I'm talking with the platform, and I'm saying this workload is, or this application is better suited for cloud provider B. So I'm just going to deploy it there. I'm just going to talk to you, the orchestrator or Kubernetes, and I'm going to let you put it in cloud provider B for me. Or I'm going to let you put it in, I want to put it in cloud provider A, so go ahead and do that. And it'll do that. It'll run your application there. If you want to switch cloud providers, for example, maybe one, you deploy your application in one, they up the cost associated with running containers in that particular cloud provider, you can just as easily deploy that application to another cloud provider back on premise because you're speaking a universal language, and that universal language is Kubernetes. You're talking the same talk, and they all understand this because they're all Kubernetes-based container platforms. So you can scale, you can add capacity very, very easily. You can run, again, containers on virtual machines, and then you have some flexibility for deployment. In fact, all the cloud providers do this. It gives you the ability to scale out very, very easily without having to wait. And waiting is sort of the killer of innovation. So we don't want to wait. We want to do things fast so that we can be innovating with the tools that we need. Accelerated time to value. Again, you can scale out to different cloud providers. You can just as easily deploy or remove those applications and redeploy them somewhere else in another cloud provider without having to do an awful lot of work. So you have this ability to do rapid deployments. Once you're containerized, once your apps are in a container, you can deploy them very, very quickly and upgrade them as needed. And that's the security aspect of the platform. We have things like standard stuff that you'd expect in any platform, role-based access control. So you can wrap around security policies, who can do what and where, which is important. But you can also do things like upgrade those applications. So we start to talk about application lifecycle. How do we manage that lifecycle? How do we manage some of those policies? How do we manage going from 1.1 of my application to 1.2? Well, you're just deploying a new container that has the new version of the application. Or you're deploying a container that has an updated dependency that had a vulnerability in it, and you're just deploying it over top of the old one. And there's different policies that wrap around how that works. You can deploy things in numerous ways. You can deploy the new container, you can shut down the old one. And if you have 10 of those, you can say, do one at a time until all of them have been upgraded. You have the power of rolling back. If for whatever reason you need to roll back, it's as easy as deploying a new container. Instead of deploying version 1.2, you're now deploying 1.1, and it operates and behaves just the same from a container perspective. So there's a lot of flexibility. Again, once you get into this containerized ecosystem relative to these points here you see. We've got a few use cases. I won't go through all of them, but I'm gonna do my best to summarize them. And really, they fall into sort of two key areas. And I want to point out the last two on this slide, Intact and Bank of Canada, were two places where we did some work. These are our use cases. The other ones are from Red Hat. So the two bottom ones are ones that we did personally. There's really two categories that these fall into. The first category is, and I'm actually going to skip to the second slide here because we have a few more use cases. The first category is really, it has to do with time. It has to do with time to value. It has to do with the amount of time that it used to take. And you can see in a couple of these examples here, 2 to 3 weeks down to 4 hours. 7 minutes, or 2 to 3 weeks down to 7 minutes. And I want to emphasize here that these aren't cherry-picked metrics that little asterisk that says results not typical. These are fairly typical. So these are the types of things that you can expect once you get into a container format. Now, some of these have additional products. Certainly when you're containerized and you're using something like Ansible to do things automatically, that helps speed up the process too. But really, again, the foundational component here is containers. The last example here with Ford is they saved money on hardware costs. They were, I guess, still doing things in their data center. And because of the high consolidation ratio with containers, containerized applications, they were able to save money on hardware costs and, of course, provisioning and everything that goes along with it. So jumping ahead, we talked about there's an announcement with Kubernetes relative to Docker. And by the way, for those that don't know, when you see K8S, that means Kubernetes. It means that there are 8 characters between the K and the S in the word Kubernetes. So if you ever see that, it's just shorthand. Kubernetes announced that toward the end of 2021, starting with release 1.2.2 of Kubernetes, they're going to drop Docker support altogether. I think the latest version is 1.2.0 something. But once they reach this milestone, they're going to drop Docker support. And the reason they're doing that is because with Docker specifically, the Kubernetes development team had to make some one-off exceptions. There was some programmatic overhead that needed to be done in order for Kubernetes to be able to work with Docker. And they had to maintain this kind of one-off approach. In development, you generally don't want to do one-off type of things. And this was true of the Kubernetes team. And they're dropping it because it's just too hard to manage. And there are other options within the ecosystem to replace Docker. And again, Andy's going to roll into that a little bit more in the technical session. We're going to talk about those replacements. So just something to keep aware of. It's more food for thought. It's this may or may not affect you. If it does affect you, maybe it's time to talk to your teams to see if there's any necessary transition planning, what that might look like, just to prepare for that change. The good news is if you're already on OpenShift, if you're an OpenShift customer and you're running on OpenShift 4 or above, 4 was released, I think a couple of years ago, a little more than a couple of years ago, they've already made this change for you. So they've removed Docker as the underlying container engine, and they've replaced it. So no work to be done if you're on OpenShift. You're good to go, all set. Red Hat's done that for you a couple of years ago. So again, if we get back to some of the value of running containers, I mean, big cost benefit, less overhead, better consolidation ratios, just as virtualization, had its play back in the early 2000s. The ability to get things into production faster. I'm going to ask a rhetorical question, and just more to think about. But how long does it take to move code changes from development into production? Is that a laborious process for you? Or is that something that you're able to do quite effectively? Containers help with that. Containers help do that and reduce that friction, give you the agility. The other thing that we didn't talk about, and I'm going to mention in this slide, containers do away with vendor lock-in. Again, I sort of talked about the open format. Because it's an open format, you're not locked into any vendor. You're also not locked into any cloud provider if you're running in a containerized format, because they're all using that open standard format. Different from virtual machines, because every cloud provider has a different flavor, a different language for virtual machine infrastructure. And really, it gives you the flexibility, gives you the control of where to run your application, regardless of the underlying infrastructure. The containerized application runs exactly the same across all environments, independent of the underlying infrastructure that they're running on. I used to do a lot of work for one of the major banks, doing cluster work, application clustering and availability. And I remember being on a bridge with a whole team of people Some of those people were doing operating system updates. I was there for the cluster updates. And then there were application folks on the call who, at the end of all of this, would go through, run their application through a battery of tests just to make sure everything's working properly. With containers, that doesn't exist anymore. That whole paradigm disappears completely. You don't do that. Nobody has to be paid overtime or have to do this kind of planning. Containers does away with a lot of that. So there's another really big benefit. If you're interested in this type of stuff, any of the topics that you hear about today and any of the stuff that Andy's going to talk about, reach out. You know, we're not going to sell you. We're not interested in that. We want to just have a conversation. We want to understand where you're at today, what your objectives are, where you want to go, and how do we get you there. And our approach is really, we take a bit of a discovery approach. We look at what you have, what your processes look like. An awful lot of times folks have great processes, but they may not be automated. They may need some help there. So we take those good processes, we automate them, and we streamline things so that we can get, again, all that innovation that happens in development out to production faster with all of the checks and balances in place that you need for your environment, all the integration points and approvals and things like that. And we're passionate about doing things like that. So if you're interested, please get in touch. We're info at HighVail, like highavailability.com. If you do get in touch and you are one of the first 20 people to book a discovery session with us before the 24th of March and attend that discovery session, we'll give you a $100 Amazon gift card to sweeten the deal. Some good stuff you can get on Amazon these days. And with that, I'm going to turn things over to my colleague, Andy, and he's going to present the technical side of things. So Andy, I'm just going to switch over to you.
Okay.
And there you are.
Okay. Let me share my desktop and get to the right screen. There we go. Minimize this guy. Oh, hello everybody. So name's Andy Prowse, technical consultant and trainer at HighVail. So as the sign says, caution, some technical information ahead. We're not getting too technical, but it's just a really good overview of the Docker commands, the Podman commands, and some of the follow-on tools, Builda and Scopio. Oh, why didn't that go there? Let's hide this guy. There we go. Okay, we all know Kubernetes is hard. Anyone who's tried to do Kubernetes, it's not the simplest thing. The end result is phenomenal, but getting there can be very tricky. Just throw it into Google. Okay. 4.8 million people can't be wrong. You get a big hit for that. So we like to think that we can make it less hard for everybody. HighVail is the consulting team, and Red Hat with some of the Red Hat tools. Together, we can make the trip to Kubernetes a little easier. So I put it in the chat earlier, the demonstration guide, and actually the PowerPoint for this material as well is in our GitHub repository. So github.com/HighVail/Podman Workshop. There's a few things in there. There's a couple of files for the demo if you want to do the demo yourself, a nice little PDF of the workshop, and again, the PDF of this presentation. So let's take a quick look at the main tool, Podman. So Podman, which is short for Pod Manager, it's an open source daemonless container engine for developing, managing, and running your containers, your compliant containers, the OCI ones that can run anywhere. It's a totally open source project. It's supported by Red Hat. It can be run on any distribution if you want free, but if you want it supported, it's part of your basic Red Hat Enterprise Linux subscription. Podman's a little more secure than Docker and the alternatives, as you don't need to be root. You run it as a regular user. So just like any application, whether you're doing like an LS or a find, you can run Podman. So that means you could be running the exact same container, it called the same container as 5 other people on the same server, and you don't tread on anybody else's containers. You don't see their containers, and they don't see yours, which is extremely secure. And it's simple. Why is it simple? They've made it to be exactly like Docker when you run Docker. So you don't have to learn anything new, except for the enhanced commands within Podman. And we'll touch on a couple of those later on. So really, all you do is you type Docker instead of Podman. So that's just some of the things I touched on before. There's no need to start or manage a daemon process. So therefore, it's simplified. Podman runs right there. You're not having to talk to a daemon in the background to run everything for you. Podman and Docker images are interchangeable. We're going to build a couple of images in both, well, an image in both, and just see how interchangeable it is. As I said, Podman does more than Docker for Kubernetes. We're going to do some neat things with a running pod and with Kubernetes. And that will be generating a Kubernetes manifest from running containers. And the biggie, the commands in Docker work the same as Podman. So, but what really helps is CRI-O. So CRI-O is your container runtime, or CRI is your container runtime interface, which allows open container initiative, so standard Docker certified, Kubernetes certified, everybody else certified containers. That's what gives you the portability between all the different orchestrators, all the different runtimes. They're all OCI compliant. So the nice thing is about CRI-O is a very lightweight Kubernetes engine that can run all these containers. So what Red Hat has done for their OpenShift container platform is they run CRI-O as their Kubernetes engine. So therefore it's Kubernetes compliant and Open Container Initiative compliant. It's the open method for running containers. So stepping on a bit more into the building of containers from a developer view, we can build containers that are CRI-O compatible without a container runtime. And to do that, it is a utility called Builda. So daemonless tool, but no runtime. So you could have a server that's there just to build containers. And just as a little side note, Builda is builder with a Boston accent, and the mascot is a Boston Terrier. So that came out of when they introduced Builda at a Kubernetes meetup 3 years ago. I could be wrong on the date, but it was kind of neat the way they named the application. And then the other application that comes in handy is Scopio. It's a container image mover. And you're thinking, well, Docker can move containers. You know, you build it, you tag it, you pull it, you push it. Why do you need Scopio? Well, and Podman pushes it exactly the same way as Docker. But Scopio can copy images between local and remote repositories. There's no tagging. There's no middle move to move something. You can say, hey, take this container and copy it right now to key.io or copy it to docker.io. You don't have to tag it with all that names, and it keeps your image listing a lot simpler. And you don't need to be escalated at all to do that unless you're going to move it to the system or to another user on the same system, and then you just have to elevate your user with sudo to do that. And again, this is all done without a container runtime, so it's secure. It could be on a DMZ just to make sure you're not, making any system a little more open or compromised. And basically, Patrick has it. You're going to move it from here to there. So the Podman commands. The goal of Podman was to ensure Docker users could easily adapt. All the familiar Docker commands exist within Podman. And the claim is made, and it works, that you could just do an alias of, Docker equals Podman, and all your scripts will work without being changed. And I mean, that says something how they could do that so well that there's absolutely no difference. And as I've mentioned, and as Matt had mentioned earlier, there's enhanced security. As Podman is rootless, it runs with user permissions. And it uses a user repository in the user's home directory. So all your images are isolated, they're secure from everybody else. Nobody can mess with your image. No one can do a Docker rm -rf of a running image and destroy your image because they don't have the ability to. Your images are yours, your containers are yours. You can use it concurrently without interfering with others. That is huge. So, but the extras, Podman really helps the developers and the operators working in and transitioning to Kubernetes. It helps you migrate your container into a pod. Because if anyone's ever had to do a manifest from scratch, they're a little tricky. So there generates K8s manifests, and we'll take a look at that. Just container concepts a little bit. Podman creates images with traditional Docker files. Builder lets you perform the imaging creation, doing from, run, expose from the command line. So build is an efficient way to create OCI images. Podman allows you to manage them and maintain those images. So without further ado, we'll pop over to the demo. Now, the way we do demos at HighVail is they're scripted, but I'm just scripting the commands against live systems because I make a lot of mistakes at the keyboard, so I like to have everything ready to go. So let's just pop over to our demo. So welcome to Podman, and I'm just going to launch the script. So an introduction to Podman, build it in Scopio. Again, github.com, HighVail Podman Workshop. So let's start off with creating a container image with Docker. We'll use the following Docker file. So it's a nice, simple 5-line file from, we're going to grab the universal basic image of Red Hat, of RHEL. We're going to install the Apache web server. We're doing it with a minus Y and Q, so we're going to answer yes automatically, and it's going to be quiet. We're going to copy our pre-existing index file to the right location in the container. We're going to expose port 80, and then we will launch Apache in the foreground. So that means as soon as the container runs, it'll go into daemon mode with Apache. So let's just go ahead and build that container. Oh, Docker's not found. Why? Because it's not part of Unix. It's not part of Linux. It's a third-party application. So the choice is to either install the unsupported version of Docker, Docker CE, and I mean, it's great. You can do everything, well, you can do everything Docker does with Docker CE. You just have no support whatsoever. Or you can purchase a subscription to a supported version, which companies, like, it escapes me right now. I can see it. Anyhow, you can get supported versions, but that's an extra cost. So let's try again with Docker CE. So we do our build. It just runs through. It's doing the 5 steps. We can see the intermediate containers it's building. The install takes a little bit of time because he's installing about 10 packages. We copy our index file. So look at that. We've tagged it as HTTPD latest, and there's our build. We do a Docker images. We can see the container name here. There's your image ID and your container. And we can also see that that's what we built it from. So that is where it was from. So let's tag it. So we're going to tag it to my repo at Docker, and let's push that to Docker. So we can see he's doing a Docker IO, my repo, Podman demo, and we're pushing that layer up. So there you go. We've built it from using Docker. We've taken a Docker file, built our image, tagged it, and pushed it. So let's take a quick view at Open Tools. Podman's part is installed as part of your basic RHEL installation on RHEL 8 and up. So we can verify this by using Docker's own hello world container. So it's not even a Podman specific container, it's a Docker specific container. So let's do run hello world, hello from Docker. Well, no, it's Podman. These steps aren't quite correct now because we're not running the Docker daemon. It's the Podman client has pulled the hello world, so these two are together. Podman created the new container, and there you go. See, it worked. Nothing to install. So just your most basic installation of RHEL as Podman. The other open tools we're going to take a look at are Builda and Scopio. They're part of the basic, well, they're part of basic RHEL. They just don't get installed in the basic install. So what we'll do, we don't have to add any repos. We just go ahead and do a DNF install. And there you go, installing them. So we've got the tools that we're going to use a little later on. So now let's go build the container image with Podman. Again, the same Docker file. We've got our 5 things, the from, the run, the copy, the expose, and the command. So Podman build latest. It looks exactly the same as Docker. And again, this is taking a little bit of time because he's grabbing the 10 packages that make up Apache and all the support files. We're copying our index file. And then we've added everything. Again, we've got our image ID right here. So let's take a look at our images. We've got our Docker hello world, which we pulled. We have our registry, the Red Hat universal basic image, and our local host that we just made 8 seconds ago. So let's tag it exactly like Docker, and we're going to push it up to key.io. And if anyone wonders why the Red Hat repository is called key, a key is a concrete or steel area that goes out into the water, which a ship pulls up to, and you load or unload things like containers onto the ship. So that's why it's called key. I didn't know that till I looked it up. I thought that was pretty cool. So anyhow, we're doing our push up to key. Looks a little different because it's, you see a little bit more information than you do with Docker. And there's nothing wrong with that. So we've pushed our Podman demo.latest up to key. So just a little quick overview. On Fedora 33, we had Docker installed. On RHEL 8.3, Podman, the commands are just identical with the exception of what we tagged and where we pushed. But outside of that, everything's the same. So let's create a container image with Builda. So we're not going to use this Docker file, but we'll look at it just for reference. We're doing our from, our run, our copy, our expose, and our command. So Builda from registry, so it's basically the first line of the Docker file. So Builda's grabbed the working container. We'll just list the container images we have within Builda. So right now we just have the one, and it's called UBI working container. So everything we do from now on will reference this container name. There we go. So let's run. So what we're doing is we're running the yum install. And so we're going to do Builda run, the Builda container image. The 2 dashes are saying because we're passing all this as an argument to run. So you need to escape it with the 2 dashes. So as we knew before, and the other 2 through Docker, through Podman, this takes about 15, 20 seconds or so. And there you go, it's complete. No output, he's just done it. A little bit different, we're creating a new index file that says Builda welcomes you to my RHEL 8 container. It's a full-blown operating website. So let's copy that to the default location within Apache. We're now going to do this part, expose the port. And now we're going to set up our command, which is going to put Apache running in the foreground. And now we're going to commit that, because right now it's just within Builda's working area. We're going to commit that to a container called HTTPD. And you can do the same thing with Docker or with Podman. if you're modifying an existing running container, you can do a commit on a running container as well. So here we go. This is the image of the container. So let's take a look at Podman images. So here's our D60B localhost. He differentiates it a little bit by saying it's local. So localhost httpd.latest. It was made 16 seconds ago. And as you can tell, because we have a different index file, we have a different image ID than we do for the Podman demo. So let's just do a little bit of moving this image with Scopio. So we're going to take that container storage localhost. Container storage means it's local to the system. Localhost is just that little bit of pathing that we saw, HTTPD, and we're going to make a tar file out of it, which you could copy this tar file out to another system, archive it if you need to, or back it up. So now we've got this. Let's take a look. So we've got this file we just created, httpd.tar, and it's about 98 meg. So we're going to elevate ourselves to the root user. We're going to copy this OCI archive because it's an open container initiative and the file is a tar, and we're going to load it locally as roots HTTPD. So he's copying the blob over. There we go. He's doing a little bit of storing. So he's registering it all for the root user. And now as root, so this isn't me, this is his root. We'll do a Podman images, and we can see the local host. So we've copied it from one user to another. You could also copy it and import it on another system. So what we're going to do now is we're going to take our container and we're going to push it up to key as Podman demo 1.0. We had called it latest earlier, but we're going to call it 1.0. So what we've done is we've taken our latest, or HTTPD latest, and without having to tag it, we've been able to push it up to key. And it looks the same with the storing of the signatures. So we're going to start this container with Podman. So we're going to start from key, the demo one. We're doing the port. So we're taking port 80 and making it available on port 8080 on the host, and we're calling it web app. So there we go. He's pulled it. And that's the running image there. So we do a Podman PS. We can see the container ID. We can see it's from key. We can see the command is HTTPD, started 8 seconds ago, well, 7 seconds ago, and we can see the port forwarding. So we do a Podman top. We can see root has launched Apache, and we can see that there's four Apache instances listening on the port. So we curl, and look at that, Builda welcomes you to my Rel 8 container. So simple. So let's export that definition for use in OpenShift. You can use it in Kubernetes as well, but I'm going to show it in OpenShift because it's kind of cool to see it in a GUI. So let's use Podman to get the container ID. We can do a Podman PS. We could be running a bunch of images or containers. So what we do is we want the latest and we want to do it quietly because we just want the container ID. So I've actually shortened it down now without the long line, so just QL. So Podman, generate a Kubernetes file manifest, and let's put it into export.yaml. And then let's take a look at that YAML file. So let's just scroll up to the top. So it gives you all the stuff that nobody knows this off the top of their head. I couldn't do it. I'd have to take somebody else's and modify it for my own use. So we have an application with a label web app, and we also have a name of the container that's labeled web app. What's the container going to do? It's going to run Apache as a daemon process in the foreground. The container, look at that, it's OCI compatible. We're going to run from key.io. So when we go up to a cluster, he's not going to have access to the local server that I'm running on. We need to be running it. We've got to be able to pull it from somewhere. So we're going to pull it as from key. We're doing our ports. So the host port's 8080, the container port is 80. So I'm going to just minimize this window a little bit. And let's bring up OpenShift. So I've got OpenShift in the background, and I'm already on the Podman HTTP project. But if it wasn't existing right now, we're just going to create it. And it says here, hey, we've made a new project. You can load an image. So let's create this with our export.yaml file. So there you go. Look at that. In OpenShift, he's bringing up our web app. It's dark blue. The web app is up. You can see he's running on this node. There's some annotations to it. Just basic, but it's everything it needs to run. And if it can run in OpenShift, it can run in Kubernetes, but you don't get the nice GUI. So let's just pop back over to this guy, full, and then we can do our describe the pod, and it gives you all the information of the pod. Again, it's basically what we saw in the YAML file. We've got the namespace, we've got the name. We see where it's coming from, key.io. I mean, it's just done. And all you did was take a running container, and now you're running in a Kubernetes cluster. So now you've got all the benefits of Kubernetes with super simple developing on your laptop. So that is the end of this part. Let me just pop back to the presentation. So again, why choose Red Hat? Well, the advantage of Red Hat Enterprise Linux is you've got your whole developer with Podman and everything. With your subscription to RHEL, you've got support. You don't get support with Docker unless you have Mirantis, that's the company, unless you purchase Docker through Mirantis. It's another subscription. It's more things to worry about. And you get better functionality and the modern functionality of running Podman. So you don't have that legacy issues with Docker, and with the Kubernetes 1.2.2 coming out, you're not stuck. And then once you do it, it's consistent and stable when you run it through Kubernetes, when you're running that on OpenShift, just the whole ecosystem. And you could really add more, do your virtualization with Red Hat virtualization. So just things to think about. For reference, OpenShift.com blog, always cool stuff on there. They had some stuff on there from the last couple of days about building your own lab. It's worth looking at weekly because they've got new stuff every day coming in. For information on what we did, podman.io and builda.io. And they're .io, so you know they're open source projects. So you can get more information on those two. And again, as Matt said earlier, if you book a virtual discovery session and we do it before March 24th, and you're part of the first 20 people, we will be glad to give you a $100 Amazon gift card. Unfortunately, Matt and I can't sign up for them because we would have by now, but they won't let us. Thank you. Thank you very much for attending this. We really appreciate it. And we'd love to hear from some of you. That's the end of this. And I think we are going to mute off everybody. I just got to get there.
Does anybody have any questions?
Just want to say hi to Andy, and thank you. That was really informative.
Oh, hey, Dave. Glad to hear from you, and we appreciate it.
How does this compare to Rancher?
Well, you could do everything what we did here with Podman. You could pick a Rancher as your, on top of your orchestrator, so your container platform.
Oh, well, that's the route we have taken at
Yeah.
this point. Although Builda and Scopio look really, really interesting.
Oh, they are. They are, especially from a scripting standpoint.
Yes, and I think as well, it might get our developers a little more involved in the whole thing.
Oh,
which, you know, a few of them are delving into it, but it seems like the infrastructure people have to hold them up all the time.
Yeah, but yeah, once you can, yeah, you get the developers in there, they do their orchestration, it just becomes part of the whole process.
Yeah, they're using what is it? The single instance of Kubernetes, Kube something or other.
Oh, Minikube.
A Minikube, yeah.
Yeah.
And it seems to me that the solution that you have put forward here is a far better way of going.
Mm-hmm. Yeah, no, I mean, Minikube has its benefits for sure. But just having, you know, being able to create your manifest easily from the command line. And then if you had a bunch of different pods, you could concatenate your YAMLs together. So you'd have,
right,
you know,
right,
multi-container pods. Now, what I didn't show in that manifest, the first line, I forgot to show it, it says it's still kind of in beta. I had an extremely simple one. So depending on the complexity, you might have to tweak it a little bit. But overall, I mean, like I said, it was scripted, but it was all live systems. And it took that container and made that file, and we uploaded it and ran it. So yeah, it's a good aid. Might not get you 100% of the way there, but it takes a lot of the pain out of it.
So how does, I guess the sort of big thing is do we go Rancher or OpenShift as far as managing these things?
It's whatever you want to do. I mean, there's a lot of good points for both. Then it gets into the whole support scenario. It depends. If people like, you know, like to pick a stack, you might want to pick the Red Hat stack because you like RHEL, you like Kubernetes, you like OpenShift, kind of a one number for everything. I mean, they're both compelling. They're both good to use.
There's a lot of screaming on our end with CentOS. What is?
True enough. But CentOS was never really, I know it was kind of owned by Red Hat, but it was never ever meant to be a replacement for RHEL. I mean, it made it handy. No. And actually with the stream, they're only one minor release ahead. So you're still staying with like the right kernel. Like, I don't think things will change too much from a developer standpoint. On the other side of it, you get developer licenses for RHEL. You can run up to 16 instances on that one developer license. So that might just fill the gap perfectly. Then you're not even worrying about CentOS being 2 or 3 weeks behind. You do the RHEL developer license for free, and then you just have your proper subscription for production, and you can run the exact same patch sets.
And from my perspective, I've been running Fedora for ages, and it works great. And now that I see what you've done with Podman, Builda, and Scopio, I'm really interested in looking at reworking a whole bunch of my Docker instances that I built ages ago and have left alone.
So that's the nice thing. You can take the Docker files, and I mean, you can run Podman and everything on Fedora as well.
I know. Yeah.
Yeah.
It's been being updated on a regular basis. I just haven't delved down into that environment.
Well, like a lot of people, I held off till it was like, yeah, I'm going to have to learn this.
And you've just proven that to me.
Good. Well, that's what this was. It was just kind of like a nice little eye opener for the future. And I mean, I think the big part, the driving force is the fact that Docker won't be Kubernetes compliant for version 1.22. And we didn't really get into big detail on that, but the whole reason behind that is currently Kubernetes would have to rewrite their interface to say, hey, I'm running on, Rocket, I'm running on Docker, I'm running on OCI. They would have to sort of do all the changes. So if Docker changed something, they would have to change their shim. If somebody else, Mesosphere changes something, they've got to change their shim for that. Some new guy comes out with a really killer, container engine, they'd have to write the shim for that. They said, forget that. We will publish our API interface. And starting with version 1.22, we will only talk to a container engine that honors our API. So they stop honoring other people's APIs. So that makes it easier for the Kubernetes people.
Andy and Dave, sorry to jump in. There's just one more question I just wanted to bring up in chat from Roya. She wants to know how to enable the OpenShift CLI. Are you able to speak to that, Andy?
Yeah, depending on what the OC, the OpenShift CLI, you can download from either through Red Hat in their OpenShift, or if you're running the upstream OKD, you can grab that from the OKD repo, and that's just an OCI command. Let me just quickly take a look at my. Okay, let me just share my screen quickly. No, I don't think it's part. No, I think I did grab it separately. Anyhow, you can grab it from Red Hat. I'll just quickly see if I can find it in Firefox, if it would come up. Yeah, but that OC command is just external. It gives you more. It's almost like Podman. It's like kubectl, but with extra features which are standard for OpenShift. Yeah, I'm not finding it right now, but as soon as I do, I will pop it in the chat. Actually, I've got the link to the documentation here, so I'm going to pop it in the chat now. So yeah, with that link, you should be able to find the information you need. Oh, you're very welcome. So do we have any more questions or anything anyone would like to bring up?
I'm good. Thanks, Andy.
Hey, my pleasure.
We need to get you down again.
Oh, I'd love to.
At some point.
I would like to get out of my basement too.
Well, I sit in the living room looking out at the snow. So, not too bad.
No, not too bad. So if anyone has any questions later, info@highvail.com. That'll go to Lauren, but she will send it out to us or the appropriate person. Outside of that, again, thank you very much for joining, and stay tuned. Well, I'm sure we'll do something again in the near term.
Thanks very much, everyone. Have a great day, and hopefully we'll see you next time.
Thanks, and cheers.
Cheers.